And then for the final part of today's lecture, we will discuss quickly the fundamental period of a function. So a function is called p-periodic. A function f is p-periodic if for all x in its domain you have that f of x plus p equals f of x. So basically it means that the function repeats itself after a period of p. So we know what a period is, and then we also have to define a fundamental period. So the fundamental period is nothing else than the lowest period for the function. So the fundamental period is the smallest value of p such that the function is p-periodic. The most well-known functions that are periodic are the trigonometric functions. So let's take a look, for example, at sine of theta or sine of x. If we draw it, we have in 0 a value of 0, so let's draw in red. Then my function goes up and it crosses again at pi, goes to the negative side, crosses again at 2 pi, back up at 3 pi, and so on until 4 pi. What we see is here that the function keeps repeating itself. So we have a period of either 2 pi, 4 pi, and so on, 6 pi. Every time after 2 pi or after we travel 4 pi, we get the same outlook, the same visual for the function. So here, this is 2 pi. This will be the smallest period for which that the function will repeat itself. So 2 pi is the fundamental period of sine. So we saw that sine of theta has a fundamental period of 2 pi. The same way we can look at cosine of theta, which also has a fundamental period of 2 pi. The tangent of theta will have a fundamental period of pi, because every pi, so every time we travel a pi over the x-axis, the function will repeat itself. So how can we find the fundamental period? So suppose that we have a more general form. So we do not have a tangent of x, but we have, for example, tangent of a times x, or a times x plus b. The constant doesn't really matter. Let's say a times x plus b. What is the period of this function? So when do we get the repetition? When do we get the condition that f of x plus p is f of x? So this p we have to find. So we can rewrite tangent ax plus b. This one is tangent ax plus b plus pi, because it doesn't really matter. If we add pi, we get the same function value. And now we can group them. So we can group them as tangent of a times x plus pi divided by a plus b. Why do we group them like that? Because we want to have an f of x. So here tangent ax plus b was f of x. We want to have a value which is similar for fx plus p. So in this case, this one is x and this one is x plus p. So my period here, my fundamental period, will be pi divided by a. Similarly, if you have sine ax plus b, you know that this is the same as sine ax plus b plus 2 pi. Because 2 pi is the period, the fundamental period of the sine. Then we bring this value, the 2p, into the x. So this is sine a times x plus 2 pi divided by a plus b. And so again, here we can read the period. This corresponds to my x plus p. So p is 2 pi divided by a.